For attending, and I'm going to say good morning. I don't know where y'all are, but it's morning here, and so that's what we're going to go with. Um, Today, we're going to talk about cleaning up your IBM. I see Jim's already snuck one question in there. We'll get to that a little bit later in the presentation, but we see that there. This is basically our you know list of to-dos. Um, and we'll be going down this, so I'm not going to read the list because this is what we're going to work through. Now, the first question we always start with is how much disk is enough? And I spent a lot of years as a consultant. I still do a fair bit of that sort of thing internally. And of course, the correct answer as a consultant is it depends. Another possible option is no amount is enough, especially if you have developers. They seem to be able to find a way to fill it all up. And the other, which is not a great answer, is you don't know how much is enough until you find out that what you have is already full. And unfortunately, that does happen once in a while. It could be a runaway query. It could be that developer again. Could be a lot of things there, right? Now, we like to talk about IBM disk guidelines just as a line in the sand of where we should be. If you're at 70% full or less, you're going to get your best performance. Um, IBMI is happy in that space. It's happy place, if you will. That number you might be able to go a bit above that these days. Spinning disks, as we had more stuff on them, the heads had to travel further. And so you ended up with a bit more latency in there that hurt performance. If your NVMEs are spinning, that's a completely different problem. And clearly, seek times and rotational latency don't exist on those devices. However, fragmentation can still occur. And so the number of IOs that can happen, um, and the and as a consequence, more IOs means more work for the system. Um, I see a question in the chat. Can I create a zip file that continues to zip itself until I run out of disk? And I actually believe we've done that um, in the IFS. So that's a danger. Um, you might want to try that on your test system, not on your production system. At the 80% level, it's starting to fragment a little bit more. And when you get above 90, you're starting to get into the danger zone. And what's going on there is more fragmentation, um, less ability for the system to allocate large blocks of data when you're doing things like um, you know, file reorganizations or large queries that may need to create temporary files, and those kind of things eventually fragment the disk enough that it's just not as efficient. And of course, if you hit all the way up to 100, the system's going to IPL. Now, um, part of the issue is the system won't necessarily IPL only when it hits 100. It might IPL at 99.5 or 99.3. That's kind of a random thing, but it happens actually when the system tries to allocate more storage than is available. So it's the size of the allocation request that causes the thing to tilt. And question in the chat there is a valid question. If I have 4 terabyte of storage compared to somebody who has maybe only a very small system at 200 gigs, for example, um, 90% is 400 gig of available space on a 4 terabyte system. True statement. However, typically on those systems that have more storage, your tables are bigger. So allocation requests are bigger. That's not a 100% true statement, of course, because we don't know how you use your system specifically, but we still like that 90% number because the size of the system generally grows with the size of the objects um, in most cases. So disk performance, not really going to cover this slide in great detail, but performance is important. Today, our biggest performance statement is, get NVMEs. Whoops, if I use my mouse, it scrolls. I was going to highlight that. Get into NVMEs for your storage because that's where performance is at. And internal, it turns out that's also the only thing you can buy. Now you can also have auxiliary storage pools and independent auxiliary storage pools. Need to be a little careful with those because sometimes you size them too small in terms of number of arms. But the point here is make sure that you have a plan for your storage. Work with a business partner that knows what they're doing. Um, Understand your performance footprint, and look for somebody that can actually get you a machine that's going to perform correctly. Because no matter what you do for cleanup and all of that, if the system is built wrong, you're going to have issues. So, what can we do without rebuilding the hardware and not buying a new system? So, we're going to look at three things. We're going to look at disk cleanup primarily today, and we'll touch on ASP balancing and disk reorganization a little bit later. So, starting with cleanup, I always like to show this slide because this is where disk storage began. If you're not familiar with this thing in 1956, which believe it or not is even older than me, IBM introduced the first commercial disk unit, and this thing was colossal. I've actually seen one of these in person. It's it's 5 feet tall, um, and it's got 50 platters. You can see the platters in there. You can see that mechanism. That's the head mechanism. That thing not only went in and out, it went up and down. There were only one set of heads for the 50 platters. So it had rotational latency and seek time, but also had elevator time, right? This thing held a whopping 5 megabytes, but they were cheating. They were 6-bit bytes, so no lowercase for you. Um, they did figure out though how to hook 4 of these things together, so you could get up to 20 megabytes of disk on there. And today's trends is more and more data. Some of you may have heard of AI. Some of you may already be sick of hearing about AI. But AI requires lots and lots of data to feed it, to train it, and uh, we keep more of that data online. But it doesn't mean we can just give up and buy disk unending, even though, hey, I sell disk. But eventually, you've got to clean it up because who knew? You got a lot of stuff, you got to back it up too, right? So, general rules and thinking when we look at programmers and testing and training, they need libraries. Do they really need a full copy of production? Sometimes they do, but could you cut back? Could you write a set of subset code that says I'm going to pull in, some big customers, some medium customers, and some small customers, and all the stuff that they need to make a database that has integrity but isn't full size. The other issue with that, and probably is more important these days, is not only does that eat up a lot of disk if you give them a full copy, but it may violate SOX and HIPAA and other laws as well. So that's a thing that you have to understand within your own company. We've had customers that actually run obfuscation programs for their test databases. So they change a social security numbers to some other number. They change names, they change street addresses and those sorts of things. Now, you might also say, how do I name these libraries? Because if you look at the average IBM I machine that's been around for a while, and some of them have been around for more than 35 years, because we just keep upgrading and upgrading. There's libraries in there. It might be Bob 1, Bob 2, Bob New, Bob Old, right? And, is that a good naming convention? Well, we're pretty sure they're Bob's fault, but we don't really know what Bob's doing with all of those. Again, how do we populate them? Subsetting, obfuscation. When do they get deleted? Right? How many of you have a library on your system that's been there for more than a decade and you're just not sure you can delete it? And of course, this last statement, do they get backed up? And Murphy says if you don't back them up, that's probably where Bob's doing all his work. All the code's in there. He's doing all his code changes and he's testing stuff, and that's a problem, right? If you're not backing it up. Now, on the other hand, it may be that library from 10 years ago that you're still backing that thing up every night and he hasn't touched it in a decade. And your backup time takes longer and your users are off longer, and maybe you're going to eventually run out of tape. Um, so you need to understand, should I be backing those things up, yes or no? And of course, you could just buy more because I sell disc. It works. All right. So, um, silly mouse is being real touchy. So there's a way to get data for disk of what's on your disk that's been around forever. We call this the always existed or perhaps old way. You run the command retrieve disk information for star sysbase, which is your system ASP, and then you retrieve directory information for the root of the IFS, the slash, which will include qsys.lib by default. Um, you can run it multiple times if you want to make subsets of the data. You could also use the command there, display object description, into an output file. That does give you a few bits of information that are not in retrieve disk inf. But remember, and I'll point this out several times, this is a point in time. So if you run this at 2 o'clock on Sunday morning, it will be telling you what your system looked like at 2 o'clock on Sunday morning. That could be good because you want to figure out where you were Sunday, but now it's Wednesday at 9:42 in the morning and you go, I don't remember being this full. You can go back at this look at this point in time and say, okay, yeah, we really did go up that much since Sunday. However, if you're trying to figure out where there's a lot of stuff to delete because you are at 95% full, having Sunday's data doesn't help you so much if you were okay Sunday. So good and bad there. Just remember this data is available, but it is point in time. Retrieve directory information, also a heavy IO task, also point in time. It does create two files in QUserSys, QAEZD, and then a 4-digit number, followed by O and D. That's the object in the directory. There's two files there. You need to link those. And the command that you would run there is shown. And that omits qsys.lib and the QIBM folder, so it gets a little bit of that a little bit less stuff in there. And the qsys.lib, of course, is what's in retrieve disk information anyway, so that's duplicate. So the old school reports are these guys, and we're not going to look at these in detail at all. We're only going to look at one page actually, but you can print that data in a bunch of different ways. Your homework is to go home and prompt these commands. Um, there is a lot of good information there, but remember it's referring back to that point in time data from when you collected your disk information. So this is the one page that I wanted to show because this is on, I think just about every one of the reports shows this block at the top. And the key here is that it shows for your particular system, two key columns, what percent of disk, this guy here, and then what's the size, this guy over here. And so if you look at that on this particular system, user libraries are consuming 40.58%, user directory 17.99%, and it shows unused space at 18.33. It also shows the gigabytes or megabytes in this case of how much storage that is. And if you look at the circles there, you got 18.33 in the purple circle. And what I've shown at the bottom here below this dashed line is work system status. And you should all be familiar with that command. You can see 18.33% is the unused space, and the percent ASP used is 81.73. So if you take 100 minus 81.73, you're going to get really close to 18.33. So those two line up. And then the yellow there is your temporary space. And if you've never wondered why, when your system gets to 99.9% full and it IPLs, and then it comes up and it's only at 97%, you go, well, what 2% of stuff did it delete? Because I might care about that. Well, the reality is what it does is it gets rid of the stuff in the yellow box down here in the corner, right? The temporary used is what goes away because it's temporary. Who knew? And these numbers typically will be really close. So here you see 194,649. Here you see 194,619. They will never be exact because remember, the report is point in time and work system status is real time. So just a couple things um, to, to point out there. One of the other numbers just to be aware of is if you get objects not in a library, there shouldn't be very much of that stuff. And then your QTemp libraries, again, is going to be pretty small. Um, in your temporary space is really the key one there that you're paying attention to in the case that you have a system that uses a lot of that. So, all right. So, new and even more better is SQL. IBM continues to pour in SQL services. Um, and those SQL services give us absolutely amazing number of capabilities to find things and get us some good numbers. And especially if we're in that 95, 96, 97%, and you're going, oh my goodness, what can I find to delete? Where is my where are my big users? And so we're going to show a bunch of those things. And all of this stuff, if you're on a currently supported IBM system, um, all of this is real time and it's all supported. I do see a question in the chat, is temp space cleared with IPL? And yes, it is. If you do a fresh IPL and you go to work system status, you'll see that the temporary storage used is going to be a very, very small number. It probably won't be zero because the OS itself will use a little, but it'll go way down. Could be in the hundreds of megabytes even. So how much do you have and how much is it configured? Well, SQL to the rescue. I do want to highlight one thing here. If you're using Access Client Solutions, run ACL scripts, which you should be, then the semicolon is required at the end of your SQL statement. If you're in the green screen, then you don't do that, but I'm only going to show that here on this one screen. So here we did a select statement. Not going to read the select statement, but you can see on this particular machine, the yellow with the dash there, that's the system base pool. It'll always show up that way on all machines, and it is ASP number 1. It is your system ASP, so that'll always be the same across there. And the then the number of disk units and then capacity about that. Okay, so total capacity in this case was a little over 1 terabyte, and the available capacity was 457 gigs. Okay. And then we have two independent ASPs. In this case, Star Wars and Galaxy were the two at the time. These were only for testing and playing around with, so they only have one disk unit. But this tells you what disk that you have on your system. Is what the point of this guy is. Runs very, very quickly. So let's look at the usual suspects. Where did my disk go? Well, the first thing, if I was writing a list of usual suspects, is journal receivers. I'm going to think those guys because they use up a lot of space. I'm also going to look for save files because save files also get left around and get used. Then there's journal receivers. We definitely don't want to forget those. Physical files, but remember, that's what IBMI does. So these things can get big, but with a reason. Then there's journal receivers. We don't want to forget those. Logical files with joins can get pretty big. So if you have too many of those, that could be an issue. We don't want to forget journal receivers. Spool files are on the list as well, although they don't typically use as much space as you might think. And then certainly we can't omit journal receivers from this list. Now, some of you might have noticed journal receivers on the list, and that's because these guys can chew up disk with the best of them. And if you do some things wrong, you can actually run out of disk in a pretty good size, a pretty good hurry using journal receivers if you don't have a maintenance procedure. Now, we like to say that they're like diapers and politicians. They have to be changed routinely and for the same reason. But you do have to know if backing them up before you delete them is required by your auditors and by your company policies. So what happens there is For example, you might be running Mimics. I know some of you are running Mimics, and Mimics uses journaling. But Mimics is smart enough to say, I've taken this receiver and I've completely replicated that to my target machine. And then I look at how long I'm supposed to keep my journal receivers after they're replicated. And once that timer expires, that journal receiver is removed from the system. So Mimics handles that for you. But if you're doing journaling yourself for any of a number of reasons and you just want to ignore them, I sell disk, right? But you need to be able to understand what they're used for and when they can be deleted. A system audit journal is another one, and that's where your auditors might say, no, we really need you to save those. Um, okay, I sell tapes too, but most folks don't save them. I mean, they keep them online for a predetermined amount of time, and then they delete them after that. But again, your company's policies may differ from that. Now, this SQL that we've got shown here will show the receivers that are online. And in this particular case, we ran it on one of our test systems. This is a fairly old query, as you can see from the dates. But this is all audit journal receivers, right? Audit receiver 1296, 7, yada, yada, yada. The date they were created, the date the last changed, and then how big they are. And in this case, that looks to be about 1.5 gigabytes of space, and that's the size that we have the audit journal set to click over to in the receiver. So if you run the query and you get this list, maybe it's time to clean up some of your audit journal receivers. But this is a great way to find them, and this one runs pretty quick. Um, and it will find all receivers in all libraries. It does not care where they are, who created them, or what they're used for. So you do need to be aware of that. Now, save files. Save files are great tools, and we like to blame Bob for these things, Bob, the developer, because Bob, the developer, loves to get in there and create a save file and save some data in there, and then run a test perhaps, and now he's got the data, he could restore it if he needs it. Well, when he's done testing, you think Bob ever deletes the save file? Of course not, because he's on to better and better, bigger and better things. The other thing they get used for is you have a test system, and Bob says, I want to grab some files from production. So he creates a save file in production, saves to it, copies it to the test system, and restores from it. Now you got two save files that have the data in. Did he delete either one of them? Again, of course not. He's on to using the data, right? So you run this query and you can find some save files. And in this case, we're going to see a bunch that are, this is again a demo system. And so you can see this first file, star1g, wait a minute, it's in multiple places. Now, the thing I didn't include in this particular SQL, if you flip back, you can see I didn't include the name of the library, right? I got object name, I didn't include the name of the library. But if you put the library in, you'd see these two are in different libraries. So I have two copies of this thing, and they're both, great big objects, almost 10 gigs of save file. And I got multiple copies of it. And you can go down the list. And again, an important thing here, and I like to include this in here. When's the last change? When were they created, and when's the last change? Again, this is a fairly old screenshot, but you can see this one was created in 2022, and it was last changed in 2022. Okay, so that's pretty fair. But here's one created in 2017, last change in 2022, probably because these are almost all the same. The system was restored at that point, and you do need to understand that. I want to make that point. If you take your whole system and you restore it to another system, these change timestamps get changed. And I have put in requests, ideas in the IBM world. The to say, please don't change the timestamp, the change timestamp when you restore an object from tape. Please retain it. So far, they haven't said that they like that. But if you want to go search for that and vote for it, that'd be great. So we have a question: why journal receivers contents are having junk values when you extract it using display journ? Not sure on that one. Some of the data could actually be um, uh, encoded or compressed or otherwise not visible through DisplayJourn. Generally, DisplayJourn works pretty well. We'd have to take that one offline. So let's look at physical files. Physical files, usually the largest objects in the application, but that's because it's what IBMI does, right? IBMI is a database machine. So they contain the important stuff. They're likely to grow, but the biggest thing here is deleted record space. And so we like to get rid of that. If we can, we like to change physical file to set reuse deleted records to yes. And when you have 99% of the applications today would have no issue with this. However, if you are running some old applications where records are expected to be in arrival sequence, then reuse deleted records is not a good idea because the rows could end up not being in arrival sequence. So you do have to know that about your application, but any application that's using SQL for access today is not going to care. So reuse deleted records is a good idea. But no matter what, if you have a bunch of deleted rows, you absolutely can get rid of those guys with reorganized physical file member. Now, the fun part has always been, yes, Larry, but I need an exclusive lock in order to do that. That's not been true for a long time, because you can do reorganize physical file member with the allow cancel yes parameter, lock shared update parameter, and the key one to remember is this rebuild access path star no. And I will tell you that the default for that parameter is rebuild access path yes. And that says as soon as you mash enter, it invalidates all the access paths that exist for that table. They're gone. Now they physically exist, but they don't have any data in them. They are invalid. And so if a user, 1 second after you bash enter, a user comes along and says, hey, I brought up an application and I need to use that access path, the system goes, fine then, I'll rebuild it for you. But a reminder here, this may be some of your biggest files, which is why you have to do it online, because you can't afford to have the thing off unavailable to users. So you could end up really clobbering performance, not to mention pausing work for your company. So rebuild access path no says do the maintenance on the fly. Will this slow down your rebuild? Without question. Will it slow down your users? Much less so. They probably won't even know. So you definitely want to say rebuild access path no. And do be aware that you must have the file journaled in order for this to happen. You only need after records, so that's fine. But you do have to have journaling enabled on this table in order to run rebuild access or run the reorganize with allow cancel. Very good function. Now let's say that you don't have a clue how many deleted rows you have. Well, let's spend an hour or so digging through. Nah, we're just going to show you what happens when you run that SQL. Bottom table here, this again, demo system. So we're seeing some data that doesn't help us much, but queue performance history, here's the table, and the dot then is the member, okay? And the number of deleted rows in there, number of active rows, total rows, 98% deleted. The data size is 4.8, only gigabytes here, so small table, but the data to reclaim is 4.7. So if you run this on your system, you can copy and paste this right out of the presentation, paste that dude in and run it. You'll get this query, and it sequences by most available space to delete. So if you're trying to get space back, and we have seen on some systems where the amount of reclaimable space is just colossal on some of these tables. So this is a really great tool to figure out where to look to get back those deleted rows. That's the number one thing for production tables that you need to keep around. Just finding the biggest tables Here's another SQL. Again, not going to go over that. You can copy and paste it out of the presentation. But here you can see that the biggest table is that same one that we looked at on the last guy. We had not big tables here, but you can see the number of deleted rows way bigger than the number of active rows. And remember, a table takes up the full space, including all those deleted rows. And it also takes up that space on tape. So if you do a save of these first 4 files, for example, they have a lot of deleted rows. All those deleted rows get saved. So you're going to save time on your backup as well if you have the ability to reclaim this deleted record space. So it's important both ways. Most of you, because you run a system for a company, you can probably name your top 3 or 4 or 5 tables off the top of your head. Frequently, there are things like order space, order history or inventory move history or things like that. And you just need to understand how big are they today and how big are they growing. What's my trajectory on my disk space. Now, logical files, pretty much the biggest thing you can do there is delete them if you're not using them. But how do you figure out if they're being used is one of the things. You can find some data from display file description, number of reads on the thing. Another way is poorly built access paths. If you're not familiar with this, if you build a logical file, for example, that uses a key of field A, and then you build another logical file that uses a key of field A and field B, and then you build number 3, which is A and B and C. If you rebuild them in the opposite order, rebuild logical file 3 first, then you'll have key ABC, and when you build logical file 2, you'll get key AB, and it'll say, oh, that's part of the other key already exists. Good. It'll just be a pointer. Okay. And then the same thing for the other one. Now, if you want to analyze your database, you can spend some time and, crank up some spreadsheets and look at all your keys and analyze that and try to figure out which ones you can get rid of. Or you can say, IBM I is smart. I'm going to save my library with access path no, then I'm going to clear my library, and then I'm going to restore my library. And it will build them only in the correct order because IBM I is lazy, and it says, why should I do all that extra work? I'm just going to build logical file 3, and logical file 2 and logical file 1 will simply be pointers. Now, I joke a bit because it's only 3 commands. How hard can this be? But for those of you who've never tried it, save live access path star no will make your backup run faster. Sweet. However, the restore lib could be ugly because you didn't save those paths, which is brainless work, right? Just writing them to tape. And then when you restore, it's just restoring them from tape. But if you have to rebuild them, your system is actually going to have to now spend time looking through all the tables that these keys are on and rebuild the paths. And if you've never done that, it can be ugly. So if you think you want to try this during a system migration, maybe a trial migration when you're practicing, this might be a good time to figure out, is it worth doing? Will I save enough space to make it worth it? And how long will it take? Right? We probably wouldn't do this on a weekend on a whim to say, hey, let's just do this. How bad could it be? Don't like those words. They're right after hold my beer, right? It doesn't come out well. To figure out who owns the most stuff, this guy here will show you who owns the most stuff on your system. And again, if you run an application, there's a pretty high probability that you know who owns the most stuff, and it should not be a person. It should be typically a group profile or an application owner. If you run Mapix, for example, it might be a Mapix user, and that guy should own all of the objects in the system. In this case, we left the names to protect the guilty. No, we didn't protect them very well, did we? But these are folks that present at common conferences and stuff, and this is a test system we use for that. And so you can look down this list and recognize some of these names, probably most of them actually. Um, but it shows how much storage each of those users has. And probably the biggest use for this is if you are running a system where the stuff should be owned by an application owner, and you go in there and you say, well, why is that Scott guy own so much stuff? He shouldn't own anything. Let's go figure out what Scott's doing why he owns so much stuff, right? Because that could end up costing you security problems in the future. So, um, and you see here we're fetching 10 rows only. So, certainly again, you'll be able to copy this out of the presentation, modify that however you'd like. Next one, detail. So we found in this screen, Cecilia has the most stuff. Well, what is that stuff? Right? And this will show all the things that she owns. And then in this case, we got a physical file, we got a save file, another physical file, another save file. But again, you can see what that stuff is. So the previous query showed us who owned a lot. This guy will show us what it is that they own. Now, spooled files. We mentioned spooled files a little bit. Too many spooled files is too many spooled files. Well, yeah, that's a great statement there, Larry. Um, Clearly, some of you save a lot of files. I've had customers over the years that create a new output queue at the end of every month, and they put the entire set of reports from the month end in that output queue. Cool. I sell disk. This is goodness. Now you can run into some issues if you have a system with a very large number of jobs that run through it, because those spool files, if they're connected to a job, are then consuming a job control block. But if you put those output queues in an independent ASP, then you don't have that issue. Um, a big offender in some systems is job logs, right? And you maintain those with the cleanup parameter. So if you run change cleanup and specify 4 for system printout, those will be cleared out after 4 days. Okay. Um, reclaim spool storage can be used to reclaim the storage if you are in that panic and you go, oh my goodness. I had a customer, for example, at one point that had 1,000,004 reports in QPrint. Oh my goodness, we got to get rid of those. Well, you clear out QPrint. Well, I didn't get my disk space back. Why not? Well, because that space is in um, library QPrint, right? And the because that stuff is stuck in there and doesn't get cleaned up until you run change cleanup or reclaim spool storage. Sorry. And yes, you can run this at any time. It won't hurt anything. It will go through and all the spool space that is not being used will be removed. Now, the key there, though, is um, there's an automatic reclaim that runs by default for 8 days. In other words, you have a report in there, you deleted it, that space is now available, but the space being available is kept in the spool space because you're probably going to generate another report. And the 8 days is a week plus a day, right? A week plus a holiday, typically. If you really need the space back, you prompt reclaim spool storage and you say days of 0. Okay, that's the only way to get the space back right now. But you can run that, right now if you'd like, and it won't affect the system at all. Who has the most? Here we can run a query, and this just tells us how much spool space is consumed by any given user. Of course, there's other objects on the system, and a lot of these are not really necessarily going to be big. They could just be clutter, but here's a couple of ways to look at that. In this first one, it's all files, and in the second one is everything, but I'm saying not object type of file or journal receiver, for example. So a couple of examples here, some Management Central collections. Management Central, of course, is gone now, but here's a couple service programs. And again, this is a test system, so your mileage will be different. But here we said, you know, The above one is no journal receivers and no files. So I'm getting those odd object types. Down here, I'm getting all types of files again. So, um, you know, here's that Q audit receiver file, and I think that's the same one we've seen before from um, Cecilia Howland. Let's look at the IFS sum. Clearly, work link is your friend, um, but I'm only going to show a couple things in there, and then there's things like Linux and Unix stuff. The key thing I want to show you in work link is this is what you get in a default view with work link. Right, so I'm in a particular directory way down here, and here's a bunch of stuff. Some of you might say, "Hey, that looks like Lotus Domino files." Yeah, it is. Um, I see the link name or the object name and the type. There's no attribute or text. Nobody puts attributes and text on IFS objects. Nobody does. But this is what you get when you do option 5. If you do option 2, 2 is edit, right? This is what you see with option 2 on that same directory. Here's the name. Ooh, size. Oh, how useful is that? And it shows the owner and the last change date and the last use date. That's awesome. Who knew you could do a 2 on a directory? And yes, you can. There's also a couple things here like number 9, recursive delete. If we put a 9 next to a directory, it'll delete that directory and everything under it. Bye-bye. Gotta go, right? Very powerful tool. It's similar to RM -RF in the command line. And then option 6 is path size. So here we showed the path size on a directory. In this particular case, these were subdirectories. So there was one called Vios. It had this much stuff, and it had this many subdirectories and this many files in it. So again, really useful stuff. If you put a 6 next to a directory and it's got a lot in it, it may take a few seconds for this to populate. So be aware of that. It doesn't really seem to harm the system performance-wise, but it does, in fact, give you some nice stats. So you say, well, should I even consider this directory for cleanup? Well, in some cases, no. Here's firmware. It's got 193 megs in it total, and there's only 9 files. I mean, still, if you don't need it, you don't need it. But if I was really looking for space, I'd be down here looking at this guy because this one's got 808 gigs, right, and 9,622 files in it. So gives you some nice stuff there. Then there's the command DU, or otherwise known as DUH. Right? Sorry. DU reports it in blocks, which is 512 bytes per block. With a dash K, it gets K bytes, dash M is megabytes, and dash G is gigabytes. So here we see 3.48 gigabytes of stuff. And this is just an LS to show you what's actually in there. Now, if a directory has subdirectories, then DU by default will show each of the subdirectories as well. So you can see example here. And then this is the total. If you want just the summary, DU-G with an S will give you the summary in gigabytes. Okay. When you're in Q shell and QP2 term, either one of those, or if you've installed your own shell, typically, which you can do now in IBM RM deletes lots of things. RM splat deletes all the files in a directory, and it doesn't ask. Unix, Linux people are very sure of what they want. So RM splat, boom, did that. Thank you. RM-R, and that is a capital R. This is, remember, case sensitivity here. It smokes everything in and below it. Same thing, doesn't ask. Gone, gotta go. Since the dash character is usually the indicator for a parameter, such as here with the dash R, if you had a goofy file name like dash foo, you can do a double dash and then dash foo to delete the thing. Right? Crazy Linux stuff. And you can put names in quotes too. So here we see Fred-Fred, a file that had a dash in the name of it, in the middle of it. Now, remember those QAEZ disk files, that point in time data? This is a way to use those files from the IFS and find stuff in the IFS using SQL from the point in time. This is a very fast because you're querying tables with SQL, and IBMI does that exceptionally well. The main reason I left this really old screenshot in here is look at the second row and the third row. The object bytes allocated is 10.5 gigabytes, but the data size is 12K. Wow. This is a virtual tape. If you create virtual tapes within IBMI and when you create them, they're created tiny. And then you can specify how big the limit is. In this case, I said 10 gigs, so it actually takes a little overhead there. But I created 10 gigabyte tapes. And then I wrote to three of them. Here's tape one, here's tape two, and down here's tape three. You can see tape three only went to 2.9, so I filled these two and added another 2.9 gigs here. And then I was smartical because I got done with my test and I said, I want my disk space back. So I did initialize tape. How'd that work for me? Not so good, huh? Because while the data size is 12K, the allocated space remained at 10 plus gigabytes. So the moral of the story here is if I like virtual tapes, that's fine, but I need to understand what happens when I initialize them. If I wish to keep that space allocated so that I know it's available when I back stuff up to it, I would do this. If I wish to get the disk space back, I would delete those virtual tapes and make new ones. Okay, because then the allocated size will be a tiny little number here. So that's the takeaway from this slide. There's also SQL services for the IFS now. So here we're saying, in this case, it's QSys2 IFS object statistics. And here I'm looking in my system, there's an IBMI directory, which has all my PTFs and such in it. And so here I can see in IBMI V7R3 PTF, here's a bin file, here's the image catalog that goes with that, and the text file gives me my size. So this, again, just an example of how to use those IFS, and this is real time. Okay, this is going out and using, um, real time SQL, looking at what's on the system right now, whereas this guy was using those point in time data files that we created at the beginning. What about temp? Could you say there's nothing valuable in there? No, you cannot. Could you say that it even could get cleared at every IPO? No, you cannot. Can you say that everything in there is tiny? Once again, you cannot. So you got to keep a look on it. And I will tell you that for any of you who are listening at this moment, if you've never looked in /temp, don't do so with a full hot cup of coffee right next to you because you might spill that, dude, when you go, holy moly, that's a lot of stuff. It's crazy, right? And however you look in there, whether it's work link or whether it's, um, you know, it, it's going to be a mess. Now, this slide is a bit of an eye chart, but if you look up here, this is, work link path size. And you can see here's temp, the second line. That thing has 5.5 gigabytes of stuff, 64,500 files, and even worse, 8,363 directories. Who wants to volunteer to clean that thing up for me? Yeah, not seeing a lot there, right? It's just huge. And so then we might say, how about we use that SQL guy, right? And so we're going to use QSys2 IFS object statistics, and we're going to say, let's look in the temp path, and we want to see subdirectories, but we're going to order by 3 with a limit of 20. So order by 3 means by the third column. So the data size here, and in this case, we're going to call out, Dawn May because she's the number one user. That's the biggest, right, directory in there. And That's some pretty big stuff. Look at the size of that thing. And then Mr. Reinhardt also, look at the size of those things in temp. That's a lot of stuff in there. So, and now you got to start looking at change and change timestamps. So in this one, 2021, and this query, by the way, was run only about a month ago. So the chances that this thing in the temp folder are valid, extremely low. Very, very good chance that we can get rid of that critter. Right now, if the date was, the date I ran the query, I would say no, we can't be getting rid of that. So this is kind of a maintenance nightmare. And the thing is, it doesn't ever appear to be all that big until you ignore it long enough, and then it's big. So I would caution you to, get in there and take a look. This is what you see if you use Access Client Solutions and you go look in the folders in there. Um, it's not as useful in my opinion just because there's so much in there. You really need to get in and use some tools like SQL. In this case, it's showing a bunch of jar files that are, in this case, not very big, but it's going to page down and page down and page down forever, right? Because there's, what did we say, 64,000 things in there. Just a tremendous amount. So all those new functions came in PTFs. They're not all that zippy if you have a lot of stuff. The test system has 400,000 there, and a query of that takes several minutes. Your newer system, if you have a Power 10 with all NVMe, 400,000 is probably not going to take more than a second or two, right? This particular system is not on Power 10 and it's not on NVMe. So, but remember, point in time snapshot before with those QAEZD files, but extremely fast here when you're using those. But these guys are real time. Okay. All right, so some junk that doesn't take space. We look at some things here, for example, line descriptions and controllers and devices and stuff, because while they don't really take space, they can confuse you. They can make troubleshooting be a problem. So like a line description, if you do work line description, then use option 5 to display each one, record the resource name it's using, then look at work hardware resource star CMN and see if you even had that thing. I just was on a system yesterday. There were 20 line descriptions. How many do you think they were using? Correct answer. One, the Ethernet line. All the other ones were old EDI and old, there were TDLC guys, just all kinds of crap on there. Those don't really hurt you until you're saying, oh, this isn't working. A thing's not working. Oh my goodness. Which one of these should be on? I don't know. None of them are on. Should I vary them on? Is that my problem? Well, the answer is probably no, but you don't know that. So getting these things cleaned up is a great idea. And if you really are chicken, you can do retrieve config source, right? And retrieve it in case you need to put it back. Controller descriptions are really the same. If you just go through the list, and if the line they attach to is gone, the controller can be gone. Most of the time, if the controller is varied off, you probably don't need it. If it's varied on and active, then that's probably doing something useful, so be aware of that. For devices, there's ones for communications that tie to controllers, and that's similar there. So if those controllers are gone, make the devices go away as well. Twin X devices, if you have a Power 7 or newer, you can't even have Twin X, so just make them go away. The potential exception there is if you have a printer that you're using just to hold the output queue. You might be careful of that. Virtual workstation devices, man, I've deleted over 10,000 of those in a single pass because the customer set, queue auto vert to no max and just let them pile up. Get rid of those silly things. If they're QPA dev, you can probably just smoke them because they'll rebuild anyway. So great thing to have on your monthly cleanup list. Save files. In many cases, save files, get created for a single use and never get deleted. And of course, that just uses up disk space. One of those is PTF images. So those are named Q plus the PTF ID. So like a QMF 12345. Um, and those are always in QGPL. Once that PTF is applied and a save sys is completed, um, those guys can go away. Disk performance and balancing, we're going to touch on this. This really doesn't take a lot of work because to disk reorg, you just run start disk reorganize, strdsk-rgz. And to end it, if you need to end it, it'll end by itself. You can run end disk reorganize. And what does that do? It's like defrag for I. It takes all of the tables that are broken into lots of little spaces all over your disk and groups them into bigger spaces, thus allowing for significantly better performance for some activities. Because instead of the system having to go to 150 places to find or 1,000 places to find the data, in the case of a query, it only needs to look in a few. ASP balancing, you can do trace ASP balance to collect data, and then you start ASP balance by usage. But today with NVMEs and that sort of thing, for the most part, I would just do start ASPAL, start capacity. And the only time you would need this even is if your disks have become out of balance because you've been deleting a lot of stuff and you do want them balanced. And this start ASP balance, start capacity will do that and run in the background until it's done. You can just run that and virtually never will it cause any issues at all. Completely runs in the background. Spool files, we talked a little bit about, but if you set Q spool file action to detach, they disconnect from the job, so it gets you your job control blocks back, uses less storage, makes your IPLs go faster. Your job logs won't be found with work job, of course, because the job is gone, but you can use work job log. And then work spool file, if you look here, there's a section that was new all the way back in 5.4 where you can specify the job name or the date and time, right, for that job. So you can find the stuff that way because the job control blocks are gone when you do the detach. You can also find them in Navigator for I. So here's just an example of how to find them there. Putting them in an independent ASP can be helpful because in an independent ASP, now they are automatically disconnected. And on older systems, this might be a way to save yourself some expensive disk by buying small or really big slow disks. These days, we just kind of put in enough NVMe to run it all. But you can also put more spool files in an independent ASP than you can in sysbase, which is a little known fact. Job logs, we talked about those a little bit. Q log output controls how they're produced. If you say job end, then it uses some CPU at the end of the job to create it. But if you say job log server, those things get sent off to a single job that produces them as it has a chance. And if you say star pend, then they don't get produced at all, and you can view them with work job log. And that's my favorite because nobody prints these things anymore except in rare case where they need to look at one or two. So just work job log will find these pending guys, and they're never even in an output queue. So nice there. Here's what you see when you do work job log, and here's these are in spool state, so they are in an output queue. But if they're star penned, then in either case you can display them here, so that's not a problem. All right, so thank you. We got done just under the wire. We got, what, a minute? No, we have 30 seconds. See if we have any other questions. Is there going to be a PowerPoint? Yep, you'll get that. Reclaim spool storage can run anytime. Yes. Deleting an image catalog, you get all your space back right away. That one's easy. As soon as you delete it, it's gone. Can you use ACS IFS view and sort by size? I haven't tried that, but I suspect you can because I think you can sort in any of the columns. Yeah, old stuff in temp. Yeah, if the last change date is very old, then that would be the things you can assume that those are um, not being used. All right.
Awesome. Well, thank you so much for attending, everyone. And thank you to Larry for sharing all of this information with us. If you would like to watch this session again, the recording will be up within 24 hours here in the portal. And then if you're looking for any kind of handout or just access to the slides, we'll be sending a survey out after the event ends, so you can get access to that as well. And then we're going to start with a 15-minute break here until the next session. So grab some coffee, answer some emails if you need to, and then we'll see you back for the next session at 10:45 Eastern Standard Time. Thanks so much, everyone. Have a great day.
Thanks all.